Hi, Stu Schwartz from MasterMathMentor.com. This is video AB Review 4. The topic is Graphical Solutions to Equations and Inequalities and covers the AB Manual, page 275. Many students, when taking pre-calculus or AP calculus, purchase a new calculator. It is usually from the Texas Instruments TI family, TI-83, TI-84, TI-89, TI-N-Spire, and there are others. We need to know how to use it. So far, no mention has been made of it, yet the calculator is a tool that is required in the AP exam, and about 25% of the problems is dependent upon the calculator. So it is vital that you know how to use it. This will just be a brief summary of the important aspects of the calculator as it pertains to AP calculus. There are several settings on the calculator you should make. First, so you don't get into rounding difficulties, it is suggested that you set your calculator to 3 decimal places. That's a standard in AP Calculus, and it's best to get into the habit of using exactly 3 decimal places. To do so, press Mode, and on the second line, take it off Float, which will give you the maximum amount of accuracy, which is 10 decimal places, and change it down to 3. Secondly, set your calculator to radian mode from the mode screen. There may be times you may want to work in degrees, but most of the time you will be working in radians, so just keep it in radians. There are some aspects of the calculator's operation that are confusing to students. One of them has to do with rounding. If you take 1 divided by 6 to 3 decimal places, your answer is 0.167. However, if you multiply that answer, 0.167, back by 6, you get 1.002. We know that 6 times 1/6 is equal to 1. Why are we getting this extra 0.002? The reason is that we are not actually multiplying 6 times 1/6. We're multiplying 6 times 0.167. We rounded 1/6 to 0.167 to 3 decimal places. This is a rounding error, and we end up getting 1.002. If we take 1 divided by 6 again, we get 0.167. If we then press the answer button, which is in second and then the negative sign at the bottom of the calculator, we multiply that by 6, we get exactly 1.000. The answer key gives us the last answer that the calculator calculated, in this case 1/6. It does not use 0.167. It knows that there are other decimal places there, and when multiplying will give us the answer 1.000. The moral of this story is never do any rounding until the very, very end of the problem. Have your answers stored on the calculator if you need to use them again. You can store these in variables using the STO key. It is important to do this, or you can make mistakes that will perhaps change the final answer 1 or 2 decimal places, and that could make a difference in the actual points that you get. It is okay to write down an intermediate answer to 3 decimal places, but don't actually retype that value into the calculator. Have it stored. I'm sure that most students know that to enter an equation for graphing purposes, you put it in the y equals menu. There are 10 equations available to graph simultaneously. Usually you only do one or two. So if we wanted to look at y is equal to x squared minus 10x minus 7, we input that into y1. The x button refers to the x, t, theta, n button on the calculator keyboard. And when you are set to function mode, when pressing that, you will always get an X. Most students are aware that to see the graph, usually you start off with a zoom 6. That will draw the graph in the standard window, x running from negative 10 to 10 and y running from negative 10 to 10. However, many functions will not fit within that window. A good way to show the graph in a window is to establish your x-min and x-max. In this case, we would like to look at this function from negative 3 to 12. We then press zoom 0, called zoom fit, and what it will then do is adjust the y values to show all the behavior of the graph. So in doing this, we see the graph, and the y min and y max have been generated as negative 35 and 3, and that will show all the important behavior of the graph. In this case, the graph just has a vertex and it opens up. Frequently, we would like to evaluate an expression at some value. For instance, we might want to find the value of x squared minus 10x minus 7 at x equals negative 4. To do this, once we have y1 as our function, we will use y1 parentheses negative 4, and we get 49. In order to get the y1, you will press the vars button and then arrow right to y vars and choose y1. Then put a parentheses and then a negative 4, making sure you hit the negative sign and not the minus sign. There are a great number of things that we can do with our function, and these are indicated in the calc menu, which is second trace. Number 1 is finding the value of a function at some constant, as we've just done in the previous screen. We could also find zeros of functions, minimums and maximums, meaning where the curve hits a low point and curves hits a high point. We can find intersections of functions and take the derivative and the integral. We will leave the last two for our calculus section, and we will also deal with 3 and 4 in our calculus work as well. We will thus concentrate on number 2, finding the zero or root of a function, and 5, finding the intersection of two functions. Let us see how we can use the calculator to solve some basic equations and equalities. If we would like to solve the equation 2x squared minus 9x plus 3 is equal to 0, we can do this graphically. We graph y is equal to 2x squared minus 9x plus 3. And then since we are trying to find the roots of it, or the zeros of it, we will use our calculate screen and choose 0. You will see the graph of the function in the window of the last function that you actually graphed. It is important to make sure that you're seeing all the behavior of the graph. Since this is a parabola, We know that it is going to open up, and therefore it has maximum of 2 zeros, as we can see. We find each zero by putting our cursor to the left of the zero we want, pressing enter, then moving the cursor to the right of the zero we're looking for and press enter. And once we do that, we will get our zero. In this case, we have 2 zeros at 0.363 and x is equal to 4.137. Obviously, since this is a quadratic, this equation can be solved with the quadratic formula. X would equal 9 plus or minus the square root of -9 squared, which is 81, minus 4 times 2 times 3, or 24. And that is all over 2 times 2, or 4. Our answer is 9 plus or minus the square root of 57, all over 4. We can find the decimal equivalent of that, and it should equal 0.363 and 4.137. In number 2, we would like to solve the inequality 2 cosine 2x minus x is greater than 0 on the interval 0 to 2 pi. So we graph y is equal to 2 cosine of 2x minus x on the interval 0 to 2 pi. When we graph, we can see that our function is above the x-axis clearly in one interval. So we still use our zero function to find the zero of the function, and we get 0.626. So our answer is that 2 cosine of 2x minus x is greater than 0 on the interval 0 to 0.626. If our function is called f of x, and we would like to find f of 2e, which would be 2 cosine of 2e minus e, we just use the y1 variable as described on the last screen and find y1 of e, and we get an answer of negative 1.393. Many times in calculus, we need to find the intersection of two equations. In this case, we're asked to find the x-coordinate of the intersection of the curves y equals x cubed and y is equal to 2x minus 3. In this case, we graph both functions, y1 to be x cubed and y2 to be 2x minus 3. We go to our calc menu and this time choose number 5, intersect. We are shown the graph in the previous window that we established. And again, we need to be sure we are showing all possible intersections of the graph. In this case, there is only one. You are asked to choose the first curve and you point your cursor to y1. Then choose the second curve, point your cursor to y2, and then you are asked to guess. This is required because if there is more than one intersection point, you need to get close to the one you are looking for so the calculator can find it. You can move your cursor just to get close to that point. And in this case, we find that there's just one intersection point at x is equal to negative 1.893. If there are multiple points of intersection, sometimes it is easier to deal with just one graph rather than two. So we set the two curves equal to each other, x cubed is equal to 2x minus 3, and therefore bring everything to one side and we get x cubed minus 2x plus 3. Sometimes there will be a nice algebraic solution. In this case, there isn't. But now we can use the zero feature of our calc menu to just find out where the curve hits the x-axis. So we graph the function again, making sure that we see all the behavior of the graph in all possible places where it intersects the x-axis. In this case, there's only one, and then we use our zero function of the calc menu to find the x value, and that in this case will be the same, -1.893.